This is my fourth video lesson for Unit 11. In this lesson, we'll be determining the concentration of a solution. Go to page 15 in the class packet. Motivation. According to the information given, which beaker is more concentrated? Take a moment to look at Scenario 1 and Scenario 2. From the previous lesson, concentration is based off the number of particles that is dissolved in solution. So in Scenario 1, we're first going to count the number of water molecules and solute particles in each solution. In solution A, there are 11 water molecules and 7 solute particles, so the ratio between the water and the solute is 11 to 7. In solution B, there are 11 water molecules and also 7 solute particles, so the ratio is 11 to 7 as well. Since they are equivalent, the concentrations is the same for both solutions. In the second scenario, we're first going to count the number of water molecules and solute particles. So in solution A, there are 11 water molecules and 9 solute particles, so the ratio between the water and the solute is 11 to 9. In solution B, the number of water molecules is 11 and solute particles is 5, so the ratio between water and the solute is 11 to 5. Since solution A has a higher ratio, it is more concentrated than solution B. Learning target. At the end of the lesson, I'll be able to calculate the concentration in terms of molarity of the solution. Homework number 4, which will be a junopod based off this lesson. Concentration of a solution can be defined as the measure of the amount of solute that has been dissolved in solution or solvent. In chemistry, concentration can be expressed as molarity, percent concentration, mass or volume, or parts per million. We will discuss each one in this unit. In this lesson, we'll be focusing on molarity, which is the most common way of expressing concentration in chemistry. When a solution is dilute, it has a relatively small amount of solute dissolved. When a solution is concentrated, it has a relatively large amount of solute dissolved. Here's a diagram showing a diluted and concentrated solution. Here's another diagram showing a concentrated solution versus a dilute solution. Before we get into molarity, let's first get a better understanding about concentration. Let's look at a bunch of scenarios involving test tubes filled with solutions of food coloring. Using the picture on the right, you can try to answer questions 1 to 9 on your own. Question 1. Which test tube is the most concentrated? Dilute. So the most concentrated is test tube A, and the most dilute is H. Question 2. If pure water is added to test tube A, what will happen to the following? The amount of solute will remain the same. The volume of the solution will increase because pure water is added, and the concentration will decrease. Question 3. If more food coloring is added to test tube A, what will happen to the following? So the amount of solute will increase because you're adding more food coloring. The volume of solution might slightly increase but remain relatively the same, so the concentration overall will increase. Question 4. If two test tubes of A are mixed together, what will happen to the following? The amount of solute will increase, the volume of solution will also increase, but the concentration will remain the same. Why is that? Because the new solution has the same ratio of solute to volume as test tube A. Question 5. Test tube A is poured into test tube 1, 2, and 3 with different volumes. Which test tube, 1, 2, or 3 is the most concentrated, least concentrated, and why? All 3 test tubes have the same concentration. Why is that? Because the ratio of the solute to volume is the same in all 3 test tubes. If equal amounts of pure water are added to each test tube, 1, 2, or 3, which test tube is most concentrated, least concentrated? Test tube 2 will be the most concentrated because it initially had the most solute, and test tube 3 will be the least concentrated because initially it has the least amount of solute. Question 7 is based off question 6. Would each test tube have the same volume of solution? The answer is no. Question 8. If pure water is added to test tube 1, 2, and 3 until all 3 test tubes have equal volume of solution, which test tube 1, 2, or 3 is the most concentrated, least concentrated, and why? Test tube 2 will be the most concentrated, test tube 3 will be the least concentrated. Test tube 2 is the most concentrated because it has the most solute even though the solution volume is the same. Question 9. If test tube 2 is poured into another test tube of A, what will happen to the following? The amount of solute will increase, the volume of solution will also increase, the concentration of the solute will remain the same because the ratio of the solute to the volume of the new solution is the same as test tube A and 2. Hopefully, now you have a better understanding about concentration and how it's related to the ratio of the solute and the volume of solution. We're now going to talk about molarity, which is the most common way of expressing and calculating concentration. Molarity is the moles of solute per liter of solution. It is not the moles of solute per liters of solvent. Keep in mind, solution means the solute and the solvent together. The equation for molarity can be found on your reference table on table T. Molarity is equal to the moles of solute over the liters of solution. The symbol of molarity is uppercase M, or moles over liters. Units for molarity are molar, or moles over liters. If you see a substance in a bracket, it represents the concentration of a substance. For example, bracket O2 means the concentration of O2. Learning check number 1. A 3 molar HCl aqueous solution contains a total of what? Pause the video and resume as completed. The answer is choice 3 moles of HCl per liters of solution. Learning check number 2. Which solution is the most concentrated? Pause the video and resume as completed. The answer is choice 3 because the molarity is the greatest. Choice 1 has a molarity of 1 molar. Choice 2 will be 2/3 molar. Choice 3 is 6/4 molar. Choice 4 is 1/2 molar. Therefore, choice 3 is the most concentrated. Learning check number 3. A student wants to prepare a 1-liter solution of a specific molarity. A student determines that the mass of the solute needs to be 30 grams. What is the proper procedure to follow? Pause the video and resume as completed. The answer is choice 4. Add enough solvent to 30 grams of solute to make a 1-liter solution. So why is it not choice 2? Choice 2 looks very similar to choice 4. The reason is because the solute might not have a density of 1 gram per milliliter. Before we get into the calculations involving molarity, let's get a better understanding of the concentration of ions in an aqueous ionic compound. Let's say in a 1 molar NaCl aqueous solution, what is the concentration of each ion? Since NaCl is an ionic compound, when it dissolves in water, it will dissociate completely. It will form sodium ion and chloride ion. There's 1 molar of each ion. Because everything is 1-to-1 if you look at the chemical equation. Since NaCl has dissolved completely in solution, the solution no longer contains Na and Cl bonding together. An analogy would be if a unicycle broke apart into 2 pieces. The unicycle represents the NaCl, and each part represents the ion. Let's look at another example. Let's say there's 1 molar Na2O aqueous solution. What is the concentration of each ion? Initially, there was 1 molar Na2O. Since Na2O is an ionic compound, when dissolves in water, it breaks up into ions. In this case, there's 2 sodium ions and 1 oxide ion. So the molarity of each ion is 2 molar for the sodium ion and 1 molar for the oxide ion. Same as the previous example, Na2O will dissolve completely in solution, so the sodium ions will no longer be bonding to the oxide ion. An analogy to this will be a bicycle breaking apart. The bicycle represents the Na2O, the wheels represent the sodium ions, and the frame represents the oxide ion. Now let's get into the calculations of molarity. Let's look at the first example. A solution contains 1.2 moles of calcium carbonate in 2.4 liters of solution. The first step is to look up the equation on table T on your reference table. Molarity is equal to moles of solute over liters of solution. Next, we plug into the equation 1.2 over 2.4. That gives us 0.5 molar. Learning check number 4. What's the total number of moles of NaCl needed to make 3 liters of 2 molar NaCl solution? Pause the video and resume as completed. Using the equation, the answer is choice 3, 6 moles. Try to do examples 2 to 6 on your own. Pause the video and resume once you want to see the answers. Here are the answers. For part B, we're given mass and we have to calculate molarity. Let's look at question 7. A solution containing 10 grams of HF in a 250 milliliters of solution. What is the molarity? The first step is to convert the mass of the substance into moles. We're given 10 grams of HF. Using the equation on table T, we know moles is equal to mass over GFM. So what is the GFM of HF? Using the periodic table, it is 20. So the number of moles is 0.5 moles. Next, we plug into the molarity equation, which is moles over solute over liters of solution. We know we have 0.5 moles. To get the liters of solution, we have to convert 250 milliliters into liters, which is 0.25 liters. We plug into the equation. 0.5 over 0.25 gives us 2 molar. Learning check number 5. What is the molarity of a solution containing 20 grams of NaOH in 500 milliliters of solution? Pause the video and resume as completed. The answer is choice 1, 1 molar. The GFM of NaOH is 40. 20 divided by 40 is 0.5. 0.5 divided by 0.5 liters is 1. Try to do questions 8 to 13 on your own. Pause the video and resume as completed. Here are the answers. This concludes the video lesson. Remember to do the Junipod homework.